New for 2024 and the Future Day is a pitch competition among master students in Sweden. You will hear Karl Johansson that will present about AI, how it can be used to detect contaminations in waste flows.
Thank you to Ragn-Sells and for having this competition. I would like to begin with sort of a description of why we think that this is the solution, or at least a part of the solution, to detoxifying our waste streams. So to begin with, our case was basically to use AI to enhance recycling of waste containing toxic substances. And my name is Karl Johansson. I'm a student at Linköping University. I'm studying a civil engineering course with a focus on energy, environment, and management. I was going to be joined by my friend Gustaf Strålin, but sadly he has an exam today, so he couldn't be here. But I'll try my best to cover for him. So a little bit of background. I guess we have already heard quite a lot that is interesting to have our case. You have all seen this circular economy graph, and really we need to sort of close the loop. As we heard before, our society is currently not very sustainable, and the time and the volumes of resources that are being extracted are not sustainable in the long term. Some resources will run out in our lifetime if no new deposits are found. Obviously, new deposits are always found, but in a sense, we have a critical problem. So when recirculating materials, we want to avoid putting these toxic substances back into our society. And that is basically where our case is based on. So we focused on looking at electronic waste and the processes being used to recycle this today. E-waste is mainly a manual separation job where we use manual labor to sort out components and products that include highly toxic chemicals and materials. And this has, of course, some benefits as to why it's being used, but in the greater sense, automation is necessary to increase precision and also the amount of resources being recycled. So how do we increase the amount and the precision of waste being recycled? We think that we can use, to begin with, databases. And I was planning to ask how many people have heard about the SCIP database, but now hopefully everyone has. So using a database that has collected all products on the European market that includes toxic substances, SVHCs to be specific, is obviously a great asset in recycling. And this is not that easy to always implement in the current process. When using this type of manual sorting processes, it will take quite a long time to actually find a product, look up an article number, and then search through a database, look through all the sub-menus, and then find exactly which components include what material and which chemical substances. So that is why we want to use AI to make this process a bit simpler and faster. So humans are extremely good at like seeing objects and observing and seeing differences between things. But we are not very good at actually having a lot of data stored in our memory available for use. And that is why we want to use AI, because AI is extremely good at keeping a lot of data available for use, but it's also it can also be good at recognizing, and in some senses it can also be better than humans at observing and recognizing different products and materials. But that obviously needs a lot of training. These kind of picture recognition softwares, image recognition softwares are dependent on having large data sets of information that it can base its decisions on. And our point is to connect these types of databases, such as the SCIP database, with image recognition software. So the challenges with this is firstly to find this high quality training data. It doesn't really exist on a large scale. The SCIP database doesn't include pictures. It doesn't include information that an AI can use to then find these products in a process of recycling process. So basically connecting both of these things is part of our case. Now, this will be quite time consuming and also cost intensive. Really accumulating data is something that takes a lot of time. And we can use AI to we can speed up this transition. We can use the SCIP database, the SCIP database, and we can use AI to find training data from websites and sources on the internet. As well, we also need to build the infrastructure and the hardware in the recycling centers, and this includes sensors, cameras, obviously also a large amount of processing power. A lot of data will be handled in a short amount of time, and this will obviously have to be handled. So really the conclusions that we have drawn in our research and in our case is that AI applications will be used by almost every waste management company that works with recycling, and the implementation will be quite costly and time intensive, and most importantly, data is key. What we found is that data is really what is the deciding factor if AI is going to be used for this sorting. So what we really want to recommend if you are in this sort of business is to look into trying to start and find data as soon as possible, because the company with the best data will have the best AI model and therefore will be the most competitive in this business. And something that can be good is to also look into these already existing data sets, such as the SCIP database. Yeah.
Cool. And by that, we need to have flowers and we need to have diplomas. I will ask Anders Kiel to stand up and Lars Tolgren, because they are the two financiers of this pitch competition. So, and pictures need to be taken now. Perfect. And we look forward to hear more about this in the coming years. We will follow you definitely and be able to spread the results. So, and I think you two need to discuss more going forward, I believe. Thank you. Perfect. Thank you.